This is another slide that presents a different type of antennas. The first one here on the top left of the slide is a miniature ceramic antennas. We mostly see it on small products, which are small relatively to the wavelength in which they are operate, like cellular phones and Wi-Fi cards and modems, cellular modems, etc. These antennas are very small. They has to be located in a very specific place on the PC board that we implement this antenna on, and they are widely used, but have a lot of substitutions when we want to design miniature antennas. The next antenna is very popular very common in the military market, the dipole antenna. The dipole antenna, sometimes it comes by itself, like here, but in many cases it comes as a part of an antenna array. The big benefit of this antenna is that it has a wide bandwidth, as well as it can carry a lot of power. Mostly this antenna that here in the slide, that if you can look closer, you will see that it is made of pure metal. Pure metal means that we can feed it with a lot of power, and it's really easy to design antennas with which are made from dipoles. The third antenna here is the flat panel antenna. The flat panel antenna is mostly used in the point to multi-point markets, and also used in the repeaters market. It's a very neat and nice antenna, as it has mostly a plastic cover, which we call in the antenna language radome, that makes it beautiful and covering all the metal parts and a PC board that are inside. The fourth antenna here on the left of the middle line is the horn antenna. That is mostly used in the military market applications, and it also used for antenna labs as a calibration antenna. Okay, the fifth antenna here is the flat spiral antenna. The spiral antenna is also a wide bandwidth antenna that is dedicated for producing circular polarization rather than linear polarization. We will discuss these terms later again. The other antenna here on this line on the right side is the conical spiral antenna. Conical spiral, like the log periodic antenna, is an infinite bandwidth antenna. But the conical spiral produces circular polarization, while the log periodic antenna produces a linear polarization. In the seventh antenna here on the bottom left corner, we see a base station antenna which has a wide beam in the azimuth plane and narrow beam in the elevation plane. The wide beam uses, as I said, for base station antennas, and the methodology of this antenna is actually a waveguide that has been slotted. The slots radiates the energy and produces the antenna radiation pattern. The eighth antenna here in the middle of the bottom line is the dielectric resonance antenna. This antenna actually has a resonance frequency which is determined by the structure of the dielectric material that is attached to the probe of the connector that you can see in the slide. This antenna is also a part of the miniature antennas family. It's used mostly in products which are very small compared to the wavelength that they operate in, and also they're used in a product that doesn't have a volume limitation, and we have to hide the antenna like in military surveillance devices. The last and very popular antenna, which most of you have in your cellular phones in one way or another, is the PIFA antenna. This antenna is actually a metal structure that is folded in a way that it will fit in the limits of the volume that we have. It also can be implemented on very small products comparing to the wavelength, and it is widely used in the market. We can see it everywhere in the commercial market mostly.